line integrals. There are a number of ways to look at this. Okay, first one is where we have the integral of Fds, when it's like this, over a curve. And that's the formula for that. So that's like this problem right here. We also have this situation, which there's no formula for on the front page, but essentially you parameterize the curve and then you find the dx and the dy components from the parameterization, and then you also plug everything. I'll show you how to I'll show you how to do these as we go along. Okay, and there's also, and then this is the same concept on as far as that's concerned. Okay, and then we have this f.dr form like that. Okay, and that's where you have a vector field, and you're dot producting it with the dr, where the r of t is like a path. Okay, and that one is given by this formula. Okay, so, and this one is, the ds is, of course, is arc length parameter, but there's the formula right there. So, first thing is, it says that C is the right half of the circle. So this circle right here, the right half of the circle, oriented counterclockwise. So this is a circle, what's the radius? Okay, the radius is 2. So this is going to be at 2, and that's going to be -2. We're looking at the right half. So that's going to be right here. And that's going to come out to 2. So that's what we're looking at right there. Okay, so a parameterization of a circle. Now, this is really important. You need to memorize this or learn this or be able to look it up, I guess, because this class is, you can have notes and stuff on our exams. Okay, so a good parameterization for a circle would be this one. Cosine t, comma, sine t. And then if you'd make t according to where your circle is. So here we're going from here to, we're going from the negative y-axis up to the positive y-axis. Okay, so this angle here is negative pi over 2. Okay, so just go negative pi over 2, and that would be start from here. It would go up all the way to this, so this angle here, which is pi over 2. Like that. Okay, now, so the integral then, according to this formula right there, you're going to go from the limits on your parameterization, which is negative pi over 2 to pi over 2. Okay, and then x is cosine t. Okay, and that comes from here. And your y is sine t. So you're going to have a sine squared t. Okay, now your ds is going to be the magnitude. That's kind of like your ds right there. So this part right here, this is all this, and then this r prime of t. We have to calculate that. So that's negative sine t, comma cosine t, and the magnitude is one of the best magnitudes ever. Which is 1, yay. Okay, so that's just going to be 1. Okay, so that's your magnitude right there, right there. Okay, and then a dt on the end. Okay, great. So that means, that means it's just going to be sine cubed of t over 3. Okay, because the derivative would be, you have a 3 coming down, which cancels that 3 out. Reduce this by 1, so you get sine squared. And then the derivative of sine is cosine. There you go. So evaluate from negative pi over 2 to pi over 2. Plug pi over 2 in, you get 1. Subtract, plug a negative pi over 2, you get negative 1/3. So wait a second. I made some bad mistakes here. I made some really bad mistakes. Let me fix this. Do you guys see where I made a mistake? It's with the parameterization. So the radius is 2. That means that I have to have 2's right here. Okay, which means that when I take the derivative, I'm just going to have 2's. And so these are going to be 4's here. So that's going to be 2. Also, that's going to be 2, and this is going to be 2 as well. Which means that this is, and that's going to be 2. So that means we have, this is going to be 16. So everything multiplied by 16. And so that's going to be 32. Okay, so any questions about that one? Great, let's go on to number 2. So one thing to remember is how to do parameterizations of circles of radius r. Don't forget to put the radius on. The next one that's really important to know is how to parameterize line segments. Okay, so we have 2 line segments. The first one going from 0 to 4, 1. And the way that you do that is you take the first point and you multiply by 1 minus t. And then you take the second point and multiply that by t. And that's going to give it to you. Okay, so here, in this case, when we put the, all this is going to be 0. So we're just going to have 4t comma t. Like that. And make t go from 0 to 1. So this 1 minus t on the t makes it so that when t is, so the idea is that when t is 0, this is the only one that happens. This is gone. So you get, okay, so the idea is that r of 0 has to be the first point. R of 1 is going to be the last point. Okay, so when you plug t equals 0, then this goes away, and you get that. When you plug t equals 1, you get, this goes away, and you just get that, which is 4, 1, okay? So this gives you the first point, and then this gives you the second point if you set it up this way. Okay, so doing the same thing with that one. I'll use S. You can use T if you want. It doesn't really matter. But I'll use S just because T has already been used, so I don't want to be confusing. So again, the beginning point, multiply that one by 1 minus S or 1 minus T. And your end point, multiply that one by S, or could be T. Okay, so this is going to be 4 minus 4S, comma 1 minus S. And then this one's going to be 5S, comma 0. And if you add those together, you get, let's see, this and this, S plus 4. And this is just going to, that plus 0 is going to be 1 minus S. Oh, and also, you want T, or in this case S, to range from 0 to 1. Okay, so if you plug in S equals 0 here, you're going to get 4, 1, which is what we want to have. And then if you plug in 1, you're going to get 5, 0. If you plug S equal to 1, you get 5, 0, which is what we want for the second point. Okay, so now we're ready to go ahead and do this. If we called this one C1 and that one C2, so all this is C2 and then all that is C1, then the integral is going to be the integral over C1 of x plus 4y plus x squared dy plus the integral over C2 of the same thing. Okay, so this we only need to look at the blue one for this one. Again, that's going to go from 0 to 1. Okay, x is going to be this one. Okay, so this is x, this is y. Also, dx is going to be 4, dy is going to be 1. So you take the derivative of that. The derivative with respect to x is 4, and the derivative with respect to y to t of this is 1. Okay, now if this had not given us a constant, it had given some expression in t, then we would plug these. You would plug in 4t for x is any x that we see, and we plug in. I'm sorry. Yeah, well, we'd have to like figure out what they are in terms of. We'd have to figure out what they are in terms of t. No, actually, no, you're fine. This would be fine. If it's an expression in t, that would be fine. So I don't know what I'm talking about. Okay, so x plus 4y. So this would be, the x is 4t plus 4 times t. And then dx is 4. Okay, then you have x squared, which is this one squared. So that's 16t squared. dy, which is 1. And that's all dt. Okay, and then for the second part, you've got this one right here. Again, it's 0 to 1. And this is our x, that's our y. dx is going to be 1, dy is going to be -1. Okay, so we have x, which is s plus 4, plus 4y, so it's 4 times this, 4 minus 4s. And then dx is 1. And then plus x squared, which is s plus 4 squared, times dy, which is -1. And that's all ds. Whoa. Okay, so I guess we have to simplify these things a bit. Okay, so this is 32t, and this is 16 plus 16t squared. And then this one is a mess. I get 8 minus 3t minus, I'm sorry, at 3s minus s plus 4 squared. So that's that piece there. Now integrate. So this is going to be 16t squared plus 16t cubed over 3, and that's evaluated from 0 to 1. And then here, this is going to be 8t minus, 8s minus 3s squared over 2 minus s plus 4 to the third over 3. And that's evaluated from 0 to 1. Okay, for this one, I got, if you put a 1 in, you're going to get 16 plus 16 thirds minus 0. And then this one's going to give you 8 minus 3 halves minus 5 to the third. Okay, then subtract and put a 0 in. So that's going to be put a 0 in here, you get 4 to the third, that's 64. Okay, so in all, $15 halves. Okay, so you guys have any questions about that one?
No, that seems to make sense. So for the first point, in RT and RS, you always multiply it by 1 minus?
Yes. The first point is multiplied by 1 minus t, 1 minus s.
And then the second point is just T or S.
Yeah. Yes, exactly.
Okay, thank you.
That's for parameterizing line segment. When it says line segment. This is a line segment in 3 dimensions. So that's the same thing. So to parameterize that one, it's 1 minus t times the first point times plus t times the second point. So what's that? 1 minus t comma 0 comma 0 plus 3t, t, and 4t. So let's see. 3t plus 1 minus t, that's going to be 2t plus 1. And then 0 plus t, that's going to be t. 0 plus 4t is 4t. And t goes from 0 to 1. And you can, it's always a good idea to double check yourself here. So if you plug a 0 in here for t, then that and that goes away. You get 1, 0, 0, which is the first point. And then when you plug t equals 1 in, we should get this point. And we do, because you get 2 plus 1, you get 3, and then 1, 4. So just double checking that this formula right here works. Okay, so this is our x, this is our y, and that's our z, right? So dx is going to be 2, dy is going to be 1, and dz is going to be 4. Okay, so we can go ahead and do the integral. So again, it's 0 to 1, and then z squared is what? Okay, so z squared is going to be, you take the 4t and square it. That's going to be your z squared. And then the dx is 2. Then x squared is going to be this one. And then dy is 1. And then y squared is this one, t squared. And dz is 4. Okay, and then you put a dt on the end there. Okay. I forgot that's squared. Okay, so this would be 32t squared, and then this is, we'll just write it as 2t plus 1 squared, and then this is going to be 4t squared. I guess I could have added those together and made that a 36. Wait, I'm going to do the integration now. Ah. Okay, so this one is going to be t cubed. Let's see, if we divide that by 3, what do you get? 12?
12.
Yes. Okay, and then this is going to be 2t plus 1 to the third power divided by, let's see, you got a 3 coming down, right? And you also have a 2 coming out, so 6. So that gives you, put a 1 in here, it's going to be 12. Put a 1 in there, you get 3 cubed over 6. And then subtract, that's 0, that's 1/6. And 49/3 is what I get for that one. Okay, so there's another example, but in 3 dimensions of doing a line segment. Number 4. This is dealing with the other way, which is a force, which is a vector field dot product with the dr component. So this first one is asking, okay, so C1 is a vertical line segment from -1, 1 to negative 1, 0. So negative 1 is over here, and you're going this way, there. Okay, so you're looking for the, you're going to integrate along this line segment, this f.dr. Now, you can see that these arrows here are pointing in the same direction, roughly the same direction as the direction that you're going in. So that means it's going to be positive. Okay. So same direction. As the directed line segment. And then over here, for the second one, C2 is the counterclockwise oriented with radius 3. So radius 3, you're going counterclockwise. You're going this way. And as you can see, your arrows here are going in the opposite direction. Okay, the arrows, these arrows are the opposite direction of the direction that the curve is, so it's going to be negative. Okay, so opposite direction. As the curve. Okay, so let's actually do one. And let me show you what's involved. So here's the equation right here. You've already got the parameterization for the curve. So we're going to take and we're going to plug in R of t into the function, and then we're also going to take the derivative R prime of t, and we're going to take those dot product and integrate that. That's pretty much what it kind of says that we're doing. So again, it's going to be from 0 to 1. Okay, f of R of t. Well, it's going to be f of R of t. Well, we'll figure that out later. And then your dot product out with R prime of t dt. Okay, so that's the formula. So let's figure out what everything is. F of R of t. Okay, so that means that you're going to plug t cubes in everywhere you see an x, and you're going to plug in negative t cubed everywhere you see a y, and then you're going to plug in z equals t everywhere you see a t. Okay, so right here then, this is their I component and the j component and the k component. So for your I component, it's sine x, which is sine of t cubed. Okay, so are you thinking right now, oh no, we have to do this, we have to integrate sine t cubed? How are we going to do that? How is that going to happen? Well, I hope, and then you're like, oh no, how, this is like one of those exciting movies where you got to integrate this somehow, but maybe there's some kind of a twist and it turns out easier. Okay, so are you guys really excited to see what happens? Okay, now. Cosine of y, so y is negative t cubed, so that's going to be cosine of negative t cubed. And then we have xc right here for the third component, so that would be this times this. So this times this, that's going to be t to the fourth. Okay, we're going to dot product out with R prime of t. So R prime of t will be, just take the derivative here. So 3t squared, negative 3t squared, and 1. Okay, so that's 3t squared, that's negative 3t squared, that's 1 dt. Okay, so integrate from 0 to 1. We have this times this, that's 3 t squared sine of t cubed. Okay, so now you're thinking, oh, there we go. We can integrate that one, right? Okay, this one is minus 3t squared. Now, cosine of negative t cubed is the same as cosine of t cubed. Okay, because you know that cosine of negative x is cosine x, always. Because cosine is an even function. Sine of negative x is negative sine x. So sine is an odd function. So those behave that way. Okay, then you have this times this, plus t to the fourth dt. Great, so let's integrate. So the integral of that one is just cosine of t cubed. Right, because if you take the derivative, you get, wait, negative cosine t cubed, sorry. Because you take the derivative, you get, the derivative of cosine is negative sine, that will take that out. And then you have a 3t squared coming out from here, which is there, right there. And then this one is sine t cubed. And this is t to the fifth over 5. Okay, now you're going to integrate that from 0 to 1. So we have negative cosine of 1, whoa, minus sine of 1 plus 1/5. Okay, then you're going to subtract and put in 0. So this is negative cosine 0. And then these are both 0. So we put zeros in there. And so this ends up being a plus 1. So in the end, we get, adding that and that together, we get 6/5. And then we have minus cosine 1 minus sine 1. So that's just like, that exercise there was just like a movie from Hollywood. Right? Because you're like, how do you overcome this? How are you going to integrate that? And then we figured out how way to do it. And then it's like, oh, it goes downhill from there. And it's kind of a weird thing in the end, though. Cosine 1 is sine 1. Wow.
Brother Harris, I don't know what movies you're watching, but